All right. Hey, everyone. My name is Justin, and today I'm going to share about HyperLedger. How many of you guys have actually heard about HyperLedger? Okay, very few guys. How many of you have heard of, or rather, done blockchain then? A bunch of you guys, right? Use Ethereum, maybe? One of the implementations? All right. How many of you understand what blockchain is? How about that? Okay, great. More people then. All right. So this is actually the third presentation I've done. The first presentation I've done was a very early overview of HyperLedger when the HyperLedger project was just announced. And there were actually no source code. And that was back in Force Asia when I first introduced HyperLedger. The second presentation I did was in Berlin. When there was actually source code to show and stuff like that of an implementation of HyperLedger. So today, what I'm going to do is I'm going to give an overview and also hopefully get right into the code as quickly as possible and actually share with you what changes has been made and done and what's going to happen going forward in the next 3 to 6 months in the HyperLedger project. So that's what I'm going to cover today. So for those who don't know what blockchain is, in a very simple sense, a blockchain is a distributed database. As simple as that, right? But it is a distributed database with elements of smart contracts, with elements of authorization, authentication, membership services, and things like that, that you would not have found or you would not find in a distributed database. And that's exactly what a blockchain is from a HyperLedger standpoint. It's basically a distributed database 3.0, if you would like to call that. Right? So with all that fancy stuff that you want out of it within the network of peers. Why do we want to do blockchain in the first place, right? I'm sure you guys have heard a lot about blockchain from Bitcoins. You guys know what Bitcoins are, right? So Bitcoin is an implementation of a blockchain. Essentially, a very specific implementation use case of blockchain. But blockchain is the general form of what Bitcoin networks are, right? And it's meant to be transitioned across the different business organizations and business processes in order to inbuild all of that into the distributed database. Traditionally, let's take, for example, from a banking sector, banking standpoint, right? We have a lot of different parties to do clearing ledgers and clearing the money and things like that, right? There's a lot of different ledgers to be done. And traditionally, what do we do in the IT department? We create APIs, right? That's what we do. We create APIs, and then Bank 1 calls our API, I call their API. We have a customer client who creates their own application. They call my API, I call their API. There's integration issues, there's this, there's that. Basically, everything becomes a whole slew of mess. That's what happens, right? And it is, in fact, in the banking sector, this is what real life is. And there's a lot of approval processes. I'm sure you know what banks are like, right? Layers and layers of approvals and whatnot. So what HyperLedger is trying to add into the features of distributed databases is to be able to have a permission level ledger, right, that is shared and replicated, leveraging on the database, the distributed database technologies to replicate it out there so that you actually own your own ledger and it gets updated and synchronized automatically. But not only that, right? You actually only can have or see the particular hashes or particular entries in the ledger. So that means that you only have the permission and it's built into as part of the system, right? That you can actually see only what you can see. That makes it very interesting from industries that have a lot of regulations. Especially, you don't want Bank A to look at Bank B's records. You want only MOM, or rather Ministry of, no, it's not MOM. What's the ministry that? MAS, yes, MAS who can see everything, but you don't want you don't want the other organizations to see the different records, right? So you want to have those kind of flexibility, and you want to have everything that's tracked. And one of the things that a lot of times a lot of people ask me, right, in terms of a blockchain, can I actually roll back? Can I actually roll back an entry in the ledger? So one of the things that's built into part of the ledger is that it is immutable, right? You must remember that. And I get a lot of developers who ask me, hey, can I delete this entry? I made a mistake. If you want to delete the entry, yes, write another entry into the ledger that reverts back that entry, right? So everything is all tracked. Scary, isn't it? Right? And that makes it very interesting on both ends. You have accountability, and on the other hand, it's difficult to work around certain things, which is what's happening in the industry right now. So the HyperLedger has changed. The HyperLedger project has changed a lot over the past 1 year, actually about 9 months now. It was announced in the beginning of the year, and it's about 9 months now, and it's changed quite a bit. It is meant to be a collaborative effort to advance the blockchain technologies with a cross-standard industry open standard, right, to transform business transactions. So the key point is actually business processes and transactions. It's not just about money, it's not just about bitcoins, it's about processes. And you can actually map blockchain technologies to pretty much any industry out there, even in, let's say, in the manufacturing industry, right? One implementation is actually to track the materials and the bill of materials, essentially, right? Everything within the ledger itself. That's one example, and many other examples that might not have benefited from the blockchain is now considered and being looking at. And the other thing that makes it very interesting about the ledger or HyperLedger is it's meant to become a connector to connect various private blockchains together. And this is one of the things that hasn't been implemented yet, and it makes it very interesting in the near future. Which, let's say, for example, a business network in the finance industry has its own HyperLedger or its own distributed blockchain. You can connect that distributed blockchain to another distributed blockchain automatically and do permission synchronization, right? Which makes very, very interesting use cases from cross-industry standpoint. So this is something that hopefully we'll see in the next 10 years, maybe 20 years down the road. And one of the biggest problems with blockchain is it is a business network. So the entire business networks and all customers in the entire industry within the business network needs to adopt, which makes it one of the very interesting problems when adopting with blockchain, is that you can't just get any benefit if I use blockchain and my one client use blockchain and that's it, right? There is absolutely no benefit. It makes more sense when the entire organization, when the entire cross-industry actually adopts. All right, so HyperLedger, what is in scope of HyperLedger? The standards are, which is in the scope, is smart contracts. I'm sure you guys, those who are under Ethereum, it's smart contracts. What HyperLedger calls it is chain code, but it's essentially the same thing. It's smart contracts. Okay, it's literally code that's being run and executed, which I'll show you later what a chain code looks like. You have the data structures, and this ledger data structures will be standardized across the different HyperLedger projects. And this is the one main change over the last presentation I did, is that now there are two more implementations of the HyperLedger standardization, so to speak. right? The more popular one is Fabric, and there is two more which just came out, and one that's already approved, which is from Intel, which is Sawtooth, and the other one, which is Iroha, from a Japanese company, which is still in the process of being approved. So HyperLedger as a project, so to speak, is about having multiple implementations of the ledger or the blockchain, but following a set of standard data structures so that you can actually have different technologies or different implementations with their own benefits and whatnot, but still following a same standard contract, so to speak, language, so to speak, from a data structure standpoint. Membership services is part of it, which allows you to connect with your whatever authorization mechanism that you need or want, using CA, certificate authorization and all that. Validation framework, identity services, and so on and so forth, network peer services. What is not in scope is actually the development stuff, right? So the main purpose of HyperLedger, of course, is for organizations to actually make money out of it, right? And one of the things of making money out of it is actually with the operations, the specializations, the more modules to be created. From an overview standpoint, HyperLedger blockchain looks like this from a cross-implementation standpoint. You have the membership module, you have the blockchain module itself, you have the transactions, and you have the chain code. These are the three main things that are happening in blockchain, and very basic stuff. Membership handles essentially all your authorization, your registration, identity, and all of that stuff, right? Very standard. You can, there is no OAuth authorization at the moment, but it's possible to actually create a module and plug in, and that's how it's trying to achieve to be modular, one of the key benefits of HyperLedger. The main core focus is the blockchain itself, the protocol itself, and the doing actual transactions, right? That is the core of the blockchain services, which has all that stuff. Consensus. The consensus manager actually allows you to plug in multiple different consensus algorithms. So at this point of time, there's a few of them, like proof of execution, proof of things like that. There's a whole bunch of it, right? Those are the advanced, crazy algorithm stuff which I don't really want to understand, right? And how you actually do consensus, right? If you want, you can read a lot of papers from the universities themselves. The main thing is a distributed ledger. A distributed ledger is a database, full stop. Right? At this point of time, it's actually leveraging on, if I'm not wrong, on RockDB and CouchDB on the back end. Right? So it's just a database. That's it. Done. All right. The P2P protocol, right now, it's leveraging on gRPC using HTTP2 protocol. All right. gRPC versus the REST. So one of the updates, which I'll show you later, is that the REST APIs that were created previously, it's going to be deprecated in the next few versions down the road in preference for gRPC. So leveraging on HTTP2, the new specifications. And the ledger storage. The ledger storage is just blob storages. So it can be any physical hard disk, it can be any S3 or whatever it is, you can do that, right? That's where the actual content, if you want to store videos, images, whatever it is, into that storage. And of course, what is chain code? Chain code is business logic. That's it, right? So business logic that it will be run automatically when a transaction is trying to be made and approved. That's pretty much it. And the chain code, initially in the HyperLedger Fabric, which is the main project implementation, is leveraging on Golang. All right, it's written in Golang. And just very recently, only it's got approved the Java chain code. And yes, Java. Right? So one of the things, no, don't shake your head, don't shake your head. You know why? Because the thing is, the thing is for the chain code itself, it's built in such a way that it's extensible to any language. So it's just a matter of time to actually, there are shims available and written already. It's just and exposed. It's just the different languages to implement those shims, right, in order to integrate in. So if I want to have a C++ chain code, I can have that. If I want to have a Ruby, a Python, or whatever it is, I can have that. There is work being made for Python right now for chain code and the various other languages and the other implementations also, right? But for now, officially, it's Java and Go. So if you want to contribute the other languages like Rust, maybe, that'll be great, you know, to write your own chain code. All right, so that's chain code. How much time do I have? Okay, let's quickly get into the actual code. So benefits, you know, reduces, saves, removes, blah, 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 and so on and so forth. Okay, this is the one that comes into the core of what I want to share with. I mentioned there are 3 implementations right now in the incubator status, right? These are all incubated. That means that it is still, it's not even beta. It's still alpha. It's developer builds, right? So right now, Fabric, which is the main one, is version 0.6. It's still developer preview. It's written in Golang. The protocols is gRPC. It still does have the REST API, but 0.6 will be the last implementation of having the REST API implemented in it. In 0.7 or 0.8, when the first beta release comes out, it will be removed. So the REST APIs leveraging on HTTP 1.1 would be removed. All right. There is a reason behind that. It's mainly performance. So right now, the performance for doing the REST APIs, or actually calling the REST APIs, you can actually call on a standard deployment about 15 to 20 requests per second. With the move to gRPC, it goes up to about 200 to 500 requests per second, and it's a huge performance jump. That's the reason why they are going with gRPC. Java chain code support, just recently implemented with Go chain code already in there. Chain 2, which is another language in a way which I don't quite understand, but that's another one that's there. And then what just came out was the HyperLedger Fabric Client SDK, which is just a wrapper of calling the gRPCs and or the REST APIs within an SDK, which I'll show you a little bit later. Sawtooth Lake is something very interesting, which the code base just was contributed in July, I think, June, July. It's currently release 0.7. It's written in an implementation of Python. It's leveraging on REST APIs. One of the benefits, or one of the interesting implementations of Sawtooth Lake, why Intel, this is by Intel, by the way, proposal by Intel, is that it has its own new algorithm called proof of elapsed time, which leverages on their Intel software guard extension thing, which is a hardware thing for their processors. Yeah, so it's one of the consensus models. One of the consensus models, right? To do the proof of elapsed time. I have no idea what the algorithm is because it's quite complex, but it does a consensus approval. And then quorum voting consensus, right? Which is essentially I vote yes, you vote yes, you vote yes, and it all consensus say everything yes, we approve, right? So that's the consensus model. Iroha is something that's very interesting that just came out. It hasn't been approved yet for the incubator. It is written in C++. It's pure C++. It's leveraging on also gRPC and REST APIs. And it wants to actually be a lightweight blockchain implementation, so that to help address with Android phones, you know, and iOS phones. And there are a lot of interesting stuff that's happening also. One of the things that I am actually personally working on is trying to see whether if I can actually port the HyperLedger project, one of the implementation, into iOS using Swift. The entire thing. So having your phone as a node. right? That would be very interesting, and I'm working with a few guys internally to get this implementation going. So I'm actually quite excited about this. So from an application architecture standpoint, you still follow your same 3-tier architecture. You have your application, you have your API layer, and then you have your database in the backend, which is the ledger, right? There's a few differences. Now in the ledger itself, you have multiple peers. The peers form a network. Each of the peer has its own implementation of a chain code. One peer can have the same chain code as the other peer, or it can have different chain codes as long as the chain codes get approved. There is one major change going forward in the version 1.0 preview. One major change is that they're splitting up the peers. So previously peers are nodes, consenters, essentially these two. They are splitting up the trust assumptions, or rather the approvals, to another node type, so to speak, called endorsers. So which means that an endorser is not a consensus. Okay? An endorser is someone who basically says, or an application who basically says, approve. So this is one of the things, yes, think about it, right? It's not a consensus approval. It's actually, let's say, for example, doing some checks within the organization, having a physical person to say approve, or having a push notification to someone, let's say you, right, saying, do you want to approve this transaction, yes or not, right? So that's what exactly an endorser is. In order to split that peer into two away from the chain code. So right now, right, in order to do endorsement, the endorsement code is actually part of the chain code, which makes it very heavy in terms of execution. So one of the big major changes is to split that apart so that the chain code business logic only focuses on the business logic. And then the endorser part of it essentially is the approval, right? So however you do the approval, you do it under an endorser peer. That's the main change. So what does that mean? That means that now they separate the trust assumptions away from the chain code and the consensus, right? You can scale the endorsers because it's now lighter weight away from the chain code execution. Confidentiality now extracts out and moves to the endorser, so your chain code doesn't have to handle any of the confidentiality, which means, very interesting now, remember I mentioned that each of the entry in the ledger can only be seen by one person or a group of people, or role. Now with an endorser, that can actually, the endorser will be able to give approval for a particular role or a person or a identity to read that particular line of ledger, right? So that's one of the other things that an endorser can do. And then, of course, privacy. All right. There is also a big change in the implementation of the application level itself. On the application level, previously everything was very separate. The application calls the REST APIs to the HTTP server, which is and then from the HTTP process and everything actually goes out to the peer. Going forward in the future, everything will be into a native API before going out to an endorser. All right. So now it goes to an endorser to validate the actual thing, and then goes into a peer. A chain code peer. Okay. So that's that. This is a transaction flow. I'm not going to go through. I'm going to go show code. I think I have a few more minutes to show code. So all in all, this is the updates on the changes that's going to happen, major changes that's going to happen into the HyperLedger project, specifically Fabric itself. So whenever I say HyperLedger, I usually mean Fabric because that's the main implementation of HyperLedger. All right. So how do I get started? Let's see. So all the source code and everything for HyperLedger is all open source because it's under Linux Foundation. You can download from the GitHub, do a clone from the GitHub account. Let's see. Oh my God, it's so small. Can you see? Okay, hold on. Let's make it bigger. There we go. So you just clone it from the GitHub account, right? Git clone github.com hyperledger fabric.git. And one of the things is because Fabric is written in Go, so you need to set up your usual Go path and all of that stuff, right? So I'm not going to go through that. You probably know how to do that. All right, so there are two ways of getting the development environment set up. One way is actually if you're going to make changes to the actual core ledger itself, right? You would want to do a vagrant. So vagrant will set up the whole entire environment. So it's under dev-env. And you just do a vagrant, vagrant what? Vagrant start, vagrant init, vagrant what? Yeah, vagrant, right? Sorry? Yes, correct. Vagrant up. Vagrant up, right? You just have to do that, and it will set up the environment and everything will get set up. You can also set up the environment within your Mac or Linux. It does not support Windows, I think, at this point of time. Well, if anybody's interested in getting working in Windows, then sure, why not? But for Mac, you need to install a few more packages. So the fastest way is actually just to use Vagrant, right, and just keep running. There are two applications that are created. So as you can see, it's a make file. You just do a make peer or make chain tool. These are the two applications that are being created. So that peer is the main ledger, essentially, or rather the main blockchain. I won't call it a ledger. It's the main blockchain because the ledger is the database behind it, right? So it's the main blockchains, and it will create the nodes. So once give me a second. Let me just get into the Vagrant. And I don't really like to deal it with Vagrant unless I'm actually changing the core source code itself. Is it big enough? Or is it okay? Bigger. Tell me when to stop. More. Really? Okay. I don't know. It looks huge on my laptop. So yeah, so Vagrant up. Right? Great. And all the base images and everything is already there. You can actually create your own base image if you want to. All the source code is all within this project itself. So let it run. I've already created it, so it doesn't have to download all of that. There are a few ports that you need to remember. As you can see, there is the port 7050, 7051, 70 blah, blah, blah. As we can see, 7054, 7053, and so on and so forth. Right? These are some of the main ports that is required or needs to be open. How do I know what the ports are? And you can actually change the ports. All right. So if you go to peer, there is actually a core.yaml, right? Let's just do a quick see in this. This is the main configuration for your various peers. Right? If you're gonna do install and run a peer on the different boxes and everything, this will be your configuration. You can also change the configuration, so you can have one configuration and different changes to a configuration using environment variables. So each of the environment variables are essentially res dot. If you want to change the address, res dot address, and then just change it, right, in the environment variable. So that's the core YAML. Let me quickly SSH into Vagrant SSH. And everything is already copied and set up over here, right? Once you have it. So it's located under, where is it located under? I think it's located under HyperLedger. And you have all the source code here. All you need to do is just do a peer. This is the main application. You can register a chain code You can create a network. You can mainly to just do it's just peer node start. And that's how you create one node. And that's it. That's how and I've just created a blockchain. As simple as that. Well, actually, I have some socket issues, as you can see. So, not exactly. So, so this is from the source code itself, right? But if I actually want to do implementation, you guys are familiar with Docker, right? I love Docker. So one of the things is I would rather use Docker to have my peers and my member services already created. So what I do is under Docker, you can actually what is it, Docker images? Ah, yes. You can actually download the base image, which is here, HyperLedger Fabric-base image, right? The HyperLedger Fabric membership service. This is a membership service, and the peer, right? This is all generated as they change the code, right? So this is the latest version, and that's all I need, right? And then after that, all I need to do is just do a Docker compose, right? Set all my machines up. As you can see, the environment variables for the core YAML, if I want to override it, I just create environment variables here, right? And I start the node, right? So if I want to have multiple nodes, I can actually create more Docker containers and whatnot and images and just spin them up, okay? So that's from a basic level. So what happens when I do a Docker compose? What do I do? Just like that? Start? There you go. Oops. What did I do? Oh, yes. The reason is because I need to halt my Vagrant. Because the port has been binded. So I need to halt my Vagrant instance. Okay. Docker compose. Start. And I just created a membership service and a peer, right? I can have multiple peers if I want to, and that's it. I've just created a blockchain. So what do I do now? All right. So the next step is actually to register a chain code, right? Your business logic into the peer, right? In order to register a business logic into the peer, what do I have to do? That's a very good question. Compose up. All right. Now my Dockers are running. All right. So the next step is actually to register the chain code itself. You have to compile the chain code in the different languages. So I have not this one. Let me go to the chain code example 2. This is a very simple example. I have to just do a go build to build the chain code itself. So it's actual execution code, okay? And then I have to run, or rather register the chain code into the peer I want to register it to, right? So that whenever something happens, a transaction happens, the chain code executes automatically. You can register multiple chain codes, all right? So it's registered. 0.0.0 is actually pointing to my peer, which I already exposed, right, with 7051. So it's already registered with the shim and everything. So I have the execution for this. This chain code is really simple. It's just A and B, two entities. I just call it A and B. That's it. And I associate a number to it, right? And that's it. And I just do plus minus. So I just do in the query itself, I just do move number from one to the other number, the other. So very simple, right? So from a very basic level, that's the chain code. You can have very more complex chain codes, but from a basic level, that's what the chain code is. All right, so remember I said that you can actually do everything in the REST APIs, right? So I have here Postman, and it's really small. I have no idea how to. Is there a way to actually increase? I'll just zoom, okay? So the very first thing, right, is because I already set up the membership, right? So you need identity. You need to register yourself. In the membership, how do I know what the registry, rather what members I have? Let me quickly go here. Under Fabric, in the membership service, there's another YAML file, right? And this actually creates setups the certificates, the CA, the SHA, and all of that stuff. And also your users, your affiliations, your roles, your admin, whatever it is. Okay. So right now I'm just gonna use one of the default ones, which is Lucas. Right. So I'm gonna register myself. I'm gonna say, hey, I am Lucas. I'm gonna register, and let's see whether it works. Send. All right, so I'm logged in. All right, so now I'm logged in. What I want to do is I want to actually initialize. So there are a few steps to all doing peers, right? You want to initialize your backend ledger, so to speak, with some data, right? And my data is essentially A and B at this point in time. So there are a few methods in chain code. The first one is deploy. Deploy actually initializes. In these arguments, in my chain code, it takes this query arguments, it extracts it out, and just stores it in the database. As simple as that, right? I have a secure context identifying who I am, right? And just the ID of the this call. So I call it to I call it to chain code. All right, 7050/chain code. And what it does is it returns back, it initializes, right? So now the next step is I want to query what data do I have in this, right? So I do a query. So in my chain code itself, I have written implementation. Say if I have query, if whatever the query is, B, A, whatever I name it, return just the number, integer, right? So remember what I did? It's 1,000, 2,000 over here. So what is the expected if I have B? It's 2,000, right? So I query for the database, it returns 2,000. So it's correct, right? Really simple. And then now, the third method is invoke, right? So invoke it can be as complex as you want. This is the main transaction, all right? This is the main transaction. And it can be anything you want in terms of the message and whatnot. This message is really simple. It's just I'm going to transfer 100 from A to B. That's it, all right? Very simple. All right, I execute. Send, returns me, it's successful transferred, everything is okay. And the actual, basically when it fails is that if A is less than 0, essentially. So you can do all your checks in the chain code itself in order to say whether if the transaction goes in or not and gets accepted. And then, of course, each transaction forms a hash within the chain, within the blockchain. So I go to a query, a get query to chain, and essentially I have the current block hash and the previous block hash. And if I want to actually check the individual transactions, I can go to each of the block, right? Query the transactions, and it will show me the type of transaction, the ID, the payload and everything, the certificate and whatnot, and also the hash data, right? And do remember, the blockchain is just a chain of blocks, hence blockchain, a chain of blocks of hashes. It does not actually contain any data. Got it? It does not contain any data. The actual data is actually on another database, which is stored as blobs, or what we call blobs, right? And that's data. And it's stored as binary stream. That's it, right? And it's not part of the blockchain, all right? It is reference based on the hashes. You can lose your entire data blobs if you want to, where the benefit of blockchain is that the blocks of chain of the hashes are there, and that's what you want, is the records, the ledger records. The data does not matter, right? And that's one of the things that a lot of people don't get with blockchain, is that if you lose the data, it's okay, because you still have the transactions there, the actual transactions there. And that is good enough from a regulation standpoint. As a regulator, you don't actually need the data. You need just the record of transactions. All right, so this is a very basic overview of the blockchain itself from a fabric standpoint. Those who have used Ethereum, it is slightly different, I'm sure, definitely. There are a lot of concepts that are very different from the fabric. And, but the main one thing is that it is meant to be modular, it's meant to be extensible, and it's meant to have multiple peers, okay, with multiple chain codes and everything. And each of these peer can be hosted in any, basically distributed. So all you need to do is just pipe the IP address properly, and that's it. All right. So from a code perspective, that's pretty much it. So the core, oh wait, I want to show the chain code itself, the implementation of the chain code. Where is the implementation of the chain code? Over here. Okay, I'm just going to zoom in like that. So the shims are essentially init, which invoke, delete, and query. These are basically the shims. So init, is the initialization. Invoke is the invocation of, just now we saw the method invoke. Delete is to delete the entire state. And of course, the query is just to query what the thing is, right? And all the code is here. It's just to get the state and whatnot. So that is, from a chain code perspective, that's the very basic stuff. So what you usually do to start creating your blockchain is to work on the chain code itself, the different business logic within the different peers, set up the peers, and then the next step is to set up your actual application. Right? And the actual application recently, or rather a few months ago, they released the Node.js SDK for the HyperLedger Fabric client, which essentially is just a wrapper for all the gRPC calls. That's it, right? So that's all. It's just gRPC calls. You can just write for any language itself, not just Node.js. Just do a gRPC call and that's it. And then you can on your application side of things, you can just do all the calls and entries and transactions to the blockchain. All right. I should be finishing already, right? Yeah. Okay. All right. So that's that. That's how you get started. Work on the chain code. Set up the peers. Set up the membership service. Run all of that in different Docker containers, virtual machines, whatever you want, right? Attach the chain code, register the chain code to the individual peers, and then call the invocation methods to the individual peers itself. So you have, when you set up multiple peers, you have one standard main peer that you can call to, or you can call to another peer, and it will automatically propagate out to the other peers for consensus and run the other chain codes. All right. So all the automation and everything is done automatically for you in the background, and hence the beauty of distribution. Some use cases, routing codes, shared routing codes. You have vehicle maintenance. The most obvious is a financial ledger. You have letter of credit, and so on and so forth. There's a lot of things that you can base out of from an industry standpoint. The key thing is to think of the ledger or the HyperLedger as a record of transactions. That's it. Don't overthink what blockchain is. Blockchain, HyperLedger is just a transaction, a distributed record of transactions. And it can be on anything, and it transforms the business processes, right? Business processes of a business network. And that's the basic stuff of what blockchain is. All right, so there's a lot of companies that's doing it. There's communities out there. These are all the links. Later, when you get the when you get the PowerPoint slides, you'll be able to click on all that. And that's it. Is there any questions?
Is the chain code during restrictions for security reasons?
The restrictions are you must adhere to the shims, right? At this point of time, there are no obvious restrictions in terms of the amount of time and things like that to execute. It is based on the consensus model. The consensus model by default, which is what I put, is just no op, which doesn't do any consensus. So the consensus is the one that does the restriction on the chain code.
Can you make it run like an infinite loop or something?
Sure. And then it crashes.
How do you stop like contracts that are
Yeah. So that's the one thing in terms of contracts. Contracts is malicious, right? You need to control the registration of the contract of the smart contracts going in. They are still building out the what do you call that? Not the restrictions, but yeah, to a certain extent, the various restrictions that you can set. I think they call it a policy, which you can set on a separate module, right? But the policy is not it's not ready yet at this point of time.
And I was also assuming that in the future they might implement something that implement some cost on the execution time or something.
Yes. All of this is you can set it in the policy and within the consensus model. Yeah.
We have time for one more question.
That's it.
I think we're low on time.
All right. Any other questions? All right. I know it's really technical. It's quite a lot of information to absorb. Oh yes, question. Yes.
Can you interact with the blockchain directly through the chain code?
Can you write directly to the blockchain?
As in, like, you know, in like Bitcoin or Ethereum, like there's not interacting directly with the blockchain, right?
Yes.
Or the hashes.
With the hashes and everything.
Is the chain code like this makes abstractions, like you did this, write all these contracts, and then automatically there's a layer that modifies the blockchain?
You mean the ledger, right? The database. Yeah.
The blockchain. Like you, when you write the chain code, you specifically modify the blockchain.
You mean to synchronize it to the different peers? Or what are you changing? What are you modifying?
I'm confused. I just
Sorry, this is a, when you've got multiple pairs who have consensus, then a mutation on the...
Then the mutation happens on the actual ledger itself. The transaction gets approved and the mutation happens on the ledger.
But only once the consensus protocol is run.
Correct.
Yeah.
Correct. Only once the consensus model, the consensus protocol is all run and approved. Once the chain code itself has been run, and also no issues or any problems. In future, there will be one more layer, which is the endorsers. So it will be endorsers, chain code, followed by endorsers, chain code, followed by consensus. So 3 layers, right? In order for anything to be approved, in the transaction to be approved. And then in future, also I didn't really cover, transactions can be in 2 views, a single transaction and a batch transaction. So that makes the ledger even more interesting, because now you can batch transactions into as one transaction hash, right? So that batch of transactions become one immutable block in the chain, yeah, which makes in terms from a use case standpoint, even more interesting use cases can be implemented in this kind of transaction entry. All right, if there are any other questions, I'm still around. You can come and talk to me. And there's actually a lot more information that I did not actually talk about. This is just the bare level, and there's a lot of new stuff and a lot of things that are have not been implemented yet also within the HyperLedger fabric. All right. I didn't have any time to actually show you the sawtooth, but sawtooth is another one that's very interesting that's upcoming. And then hopefully in my next presentation, in the 4th one that hopefully I'm going to do, I can actually show you implementation of a peer on an iOS device, maybe. All right, thank you very much.
Thank you, Jim. If you want to talk about stuff, now's a good time. We're going to have a quick